Salam and peace be upon you. My name is Muhammad Laiq Siddiqui, the father of Holophase. Remember the language we are learning. There is one field, Phi, the holophase, a cyclic rhythm defined at every point in the universe. Its first derivatives give three simultaneous echoes: time, which we call omega, space, which we call k, and motion, which we call v, built from both omega and k. Above them, higher derivatives form a branching tree that goes on forever. Every law of nature is a pattern in this tree of derivatives of phi. Today, we zoom into just one branch of that tree. In the last part, we explored a strange and beautiful idea, that one single letter, this cyclic order we call phi, can generate infinite meaning through its derivatives. We saw how each derivative asks a different question about phi: how fast, how bent, how twisted, how drifting. And yet nothing new is ever added. It is phi all the way up. Now in this part, we walk right back down to the root. We sit with phi itself. Not its echoes, not its waves, not its nuts, just the silent page that makes everything else possible. 1. Phi as the silent page. Let us start with a very simple image. Imagine you are holding a completely blank sheet of paper in your hand. No ink, no lines, no color, just white. If you stare at it, there is nothing to read. No letters, no words, no pattern. But if that blank page were not there, you could not write anything at all. The page carries everything, even when it seems to carry nothing. Phi is like that blank page. Phi, the holophase, is the underlying rhythm that exists at every point in the universe. You can picture it, in your mind's eye, as a little hand of a clock at each point in space, always pointing somewhere on a circle, always ready to move. Here is the key. If you take phi and add the same constant angle everywhere, if every little clock hand turns by the same amount, nothing observable changes. All the differences between places and times remain exactly the same. This is what we called shift symmetry in earlier episodes. In everyday language, we never see phi itself as an absolute number. We only ever see how phi changes, how it differs from place to place, and how it moves from moment to moment. Just like you do not care about the absolute whiteness of the page, you care about the ink that breaks that uniformity. Reality does not care about the absolute value of phi, only about its differences. Phi is the carrier. The derivatives are the message. 2. Phi as the global clock hand. Now imagine something a bit more dynamic. Picture the whole universe filled with tiny clocks. At every point in space, there is a small, invisible hand going around in a circle. This is phi. Left alone, phi just turns. It is like a cosmic metronome that never stops. But remember, what matters for physics is not where each hand points on some absolute scale, but how those hands change relative to each other and over time. In time, the rate at which phi turns at a point is what we later call omega, the time echo. In space, how phi's value changes from one point to a nearby point is what we call k, the spatial echo. So even before we talk about omega and k, there is this simple picture. Phi is a continuously defined angle at every point. Only relative angles and how they vary matter. Every derivative is a question we ask about phi's behavior. If you like metaphors, phi is the global clock hand, but we never read the absolute time on that clock. We only read how quickly it is turning, how differently it is oriented from place to place, and how those differences move. In the master tree of the holophase language, phi sits at the very root. Every branch above it, every derivative, is a different way of interrogating this root. How fast do you turn in time? Omega. How sharply do you twist in space? K. How do those twists themselves change? Second derivatives, and so on. But the substance behind every question is always the same. Phi. 3. Linguistic role. Phi is the alphabet that hasn't been written yet. Inside the language of Holophase, what is Phi's role? Is it a letter, a word, a rule? The most helpful picture is this. Phi is not a letter in the usual sense. Phi is the substance out of which letters are carved. Think again of our blank page. Ink alone means nothing without the page. But you would not usually call the page a letter. Instead, you would say, letters are shapes carved into the contrast between ink and page. The page is the silent background that lets those shapes exist. In the same way, omega, k, and the higher derivatives are like the letters and accents of the language. Phi is like the field of possibility that they all share, the background rhythm that every letter deforms in its own way. So linguistically, Phi is the substrate of meaning, not yet structured. Its derivatives are the structured forms that carry explicit meaning. You can think of every derivative as a particular question about Phi. How fast is Phi turning here? How steeply is Phi changing across space? How rapidly is that steepness itself changing? Each question produces a new letter on the tree, but each answer is still only describing Phi. 4. Scientific essence. What Phi is in operational terms. Now let us translate that into something a physicist or mathematician would recognize, but in plain words. Operationally, meaning in terms of what we can measure, Phi is a phase field. A phase is a way of saying where we are in a cycle. For example, a simple pendulum swings back and forth. At any moment, you could say what fraction of its full cycle it has completed. That fraction is like a phase. A radio wave goes through repeating ups and downs. At any point in space, you could say whether it is near its maximum, minimum, or somewhere in between. That again is a phase. Now imagine that this idea of being somewhere in a cycle is fundamental. Instead of having many different separate waves, we have one underlying cyclic quantity defined everywhere. That is Phi. The Holophase framework says, all the things we call fields in physics, electromagnetic fields, matter waves, order parameters in materials, are different patterns in one deeper phase field, Phi. We do not measure Phi directly. We measure how Phi changes, in time, omega, in space, k, and in their combinations. So in scientific terms, Phi is the underlying cyclic degree of freedom. All observables are functions of Phi's derivatives. Energy, as we said in earlier episodes, is not a primitive thing, but a tally of how intense those changes are. If you want to see the full mathematical derivations of this and the exact equations that encode Phi and its derivatives, you can search for Holophase on Zenodo. There you will find the formal papers that this audio journey is built on. Here we are staying with the spoken understanding. 5. Dimensional expression. How Phi whispers in time, space, and motion. Now let us apply our core rule. Every structure in this language must have 3 echoes, in time, in space, and in motion. Even Phi, quiet as it is, has these echoes. In time. In time, Phi shows up as a continuous unfolding of phase, even if nothing appears to change in the world. Say you are in a quiet room, staring at a wall. The underlying Phi at each point is still turning. Its local rate of turning is what we call omega, the temporal echo. So Phi's temporal expression is, there is always a where we are in the cycle now. Omega tells us how that where changes with time. If we watch the frequency of light from an atom or the rhythmic oscillations in a laser, what we are really watching is how the underlying Phi at that location moves forward in time. If we could freeze space and look only at time, we would see Phi as a continuous rotation and omega as its speed. In space. In space, Phi appears as a pattern of angles across distance. Walk through a room and imagine that at each point, the little clock of Phi is pointing in some direction. The rate at which those directions change as you walk is the spatial echo, k. So phi's spatial expression is a tapestry of phases spread out across space. The steepness and shape of that tapestry are encoded in k and its spatial derivatives. We cannot see these phases directly with our eyes, but we can infer them through interference patterns, through diffraction, through the shapes of waves. When light creates bright and dark fringes on a screen, those fringes are telling us about how phi is arranged across space. In motion. In motion, phi shows up in the paths along which its phase stays constant. Imagine again the sea with long rolling waves. If you choose one crest and follow it as it moves, you are following a path along which the phase of the wave, the underlying phi, stays the same. The speed at which you must move to stay on that crest is what we later call v, the motion echo. Those velocities are not independent, random numbers. They are determined by how phi changes in time and space together. So phi's kinematic expression is there exist special trajectories where the phase does not change. Those trajectories define how patterns of phi propagate. When we measure group velocities of light pulses in a fiber, or the speed of ripples on water, we are really probing how phi chooses these constant phase paths. If a single phi could not give a consistent story across all three, time variation, spatial pattern, and propagation behavior, the holophase framework would break. The unity would be false. 6. Position of phi on the master tree. On the master tree of the holophase language, phi is the root. Above it, the first layer of branches is made from the first derivatives. Omega, how phi changes in time. K, how phi changes in space. D phi, the combined change when you move in time and space together. V, the special velocities that follow lines of constant phi. Above those, we have the second derivatives. Temporal changes of omega, how the ticking rate itself accelerates. Spatial changes of k, how the spatial pattern bends and focuses. Mixed derivatives, how time change and space change interact. And so on, up the tree to an infinite dictionary of nuances. But every single node in that tree is, in some quiet sense, just phi plus one more question. You can think of the tree like this. The root, phi, is the underlying book. The first derivatives are asking fast, simple questions about that book. What is the slope here? What is the rhythm here? The second derivatives are asking more refined questions. How is that slope itself changing? Is this pattern focusing or spreading? The higher derivatives are like asking about the style of the style, the pattern of the pattern. No matter how high you climb, you are never leaving the original book. You are just reading it more and more closely. 7. Interactions with nearby branches. Even though phi sits at the root, it is not isolated from its own derivatives. In reality, the derivatives of phi feed back into how phi itself behaves. The way phi changes in time and space is constrained by relations between omega and k, what we usually call dispersion relations, constraints coming from energy balances, which are built from squares of derivatives, topological constraints from how phi wraps around defects, which show up as winding numbers. So you can imagine that the tree is not a static diagram, but a living organism. Phi flows upward into its derivatives. The structure of those derivatives flows back down, shaping how phi can continue to evolve. For example, if the dispersion relation between omega and k has a certain form, it fixes how wave packets in that medium can move. That, in turn, constrains which phi patterns are stable and which are not. If the topology of phi creates a vortex, a place where the phase winds around the core, then phi's evolution is restricted by the fact that this winding number cannot change smoothly. So phi is both the source and the listener of its own language. The root feeds the branches. The branches tell the root how it is allowed to grow. 8. Semantic meaning. What kind of meaning phi carries? What kind of meaning does phi itself carry for the universe? At first glance, you might say, none. Only the derivatives have meaning. But that is not quite right. Phi carries a very deep, very simple kind of meaning: possibility and continuity. Because phi is defined everywhere, and because it can be differentiated as many times as we like, it guarantees that every local pattern has a context. Every small region can, in principle, be connected with its neighbors through continuous change. This continuity is what allows waves to exist, what allows fields to propagate, what allows defects to be well defined. Without a continuous underlying field, you could not talk about gradients, curvature, or topology in the ways we do. So the meaning of phi is to provide a continuous canvas on which all other meanings can be drawn, to ensure that the language of reality is not a collection of disconnected symbols, but a living, flowing script. 9. Stability, variability, and falsifiability. Now let us talk about stability, variability, and how we could test whether this whole picture is true. Stability. Phi itself is not something we can shake directly. What we can shake are its patterns. But the assumption that there is one phi underneath everything leads to strong stability claims. The rules that relate time change, omega, space change, k, and motion, v, must be the same in all systems where the same physical structures appear. For instance, in many different materials, waves obey certain dispersion relations. Links between frequency, which is omega, and wavelength, which is determined by k. The Holophase framework says, these are not coincidences. They are expressions of how one underlying phi responds to different environments. If the framework is right, then we should be able to write these relations in a single language and recognize common patterns. Variability. At the same time, phi must be free enough to generate the enormous variety of structures we see: galaxies, atoms, fluids, storms, brains. That means its derivative tree must be able to support simple wave patterns, highly curved localized structures like particles or vortices, turbulent chaotic patterns where many derivatives coexist. So phi must be flexible and constrained at the same time. Falsifiability. How could this be wrong? The Holophase claim is, there exists a single phase field phi, whose derivatives can describe the time evolution, spatial structure, and motion of all physical phenomena that unfold in time and space. To test this, we can measure how frequencies omega depend on wave vectors k in different systems: light in a crystal, sound in air, surface waves on water. From those measurements, reconstruct the implied derivative relations up the tree. Check whether the same underlying structure can account for all these cases. If we found, for example, that two systems which seem to have the same derivative structure at low orders suddenly require fundamentally different kinds of phase at higher orders, incompatible with being just different regions of the same phi, then the unity claim would fail. In plain words, if the universe refuses to be written in one phase script, the holophase program is wrong. That is how it should be. A strong claim must welcome strong tests. Again, the detailed proposals for such tests, which systems to measure, what patterns to fit, how to compare them, are laid out in the formal papers on Zenodo. Here, we are focusing on the story and the intuition. 10. Where phi appears in nature. Even though we never measure phi directly, its presence is hinted at everywhere. When you look at the interference pattern in a double-slit experiment, the standing waves on a guitar string, the lattice vibrations of a crystal, the coherent light of a laser. In all of these, the phase of some wave is the key player. We usually talk about the phase of the electromagnetic field, or the phase of a quantum wave function, or the phase of an order parameter in condensed matter. The holophase view says, these are all local dialects of one deeper language. They are all different ways that phi speaks. So whenever you see where waves from different paths combine to create a pattern of bright and dark, loud and quiet. Diffraction, where a wave bends around an obstacle and produces a pattern. Coherence, where a wave keeps a stable relationship across space and time. You are seeing phi's spinal structure, It's phase continuity at work. 11. Everyday analogies. Feeling phi without equations. Let us bring this right down to simple experiences. Music. When you listen to a pure musical tone, like a single note on a flute, there is a steady rhythm. You might tap your foot to it. That rhythm is like omega, the time echo of phi. If you listen to a chord, many notes at once, or to a rich sound with harmonics, you are feeling a more complex pattern of phase relationships. The underlying oscillations are still made of cycles, still measured by phase, but now their relative phases shape the timbre, the quality of the sound. Phi is like the invisible score that all these rhythms are written on. You never see it directly, but every harmony, every beat depends on it. Walking on hills. When you walk across a landscape of hills and valleys, you feel slope and curvature. The slope tells you which way things roll. The curvature tells you whether the slope is steepening or flattening. You can think of phi as defining a kind of phase landscape. Its derivatives, k, and the higher spatial derivatives, tell you how steep that landscape is, how it bends, where it focuses flows, where it spreads them out. You never see an absolute height that matters on its own. What matters is always the difference between one point and another and how it changes. Water waves. Stand at the shore and watch waves roll in. The regular up and down at one spot is the time echo of some underlying oscillation. The spacing between crests along the surface is the spatial echo. The speed with which the crests travel is the motion echo. All of these can be traced back to a deeper, continuous oscillatory structure. Phi is like that structure, generalized to the whole universe. 12. How to read phi in the world. Since phi itself is invisible, how can you learn to recognize its presence? Here is a simple recipe. 1. Look for regularity in time. If something repeats, a flashing light, a pulsing sound, a stable vibration, phi's time echo, omega, is speaking there. 2. Look for regularity in space. If a pattern repeats, stripes, ripples, crystal lattices, phi's spatial echo, k, is shaping that structure. 3. Look for stable ways patterns move. If something travels at a consistent speed without changing form, a soliton in a fiber, a stable wave packet, a coherent beam, then phi's motion echo, V, is expressing itself. 4. Ask whether these three, temporal rhythm, spatial structure, and motion, seem to be tied together. If changing the spacing of a pattern changes its frequency and its speed in a predictable way, you are seeing the linked derivatives of phi in action. Whenever you find such a triple link, time, space, and motion moving together according to stable rules, you are, in Holophase language, reading the signatures of phi. 13. Returning to phi, one rhythm behind all stories. Let us now bring all of this back to one simple sentence. Phi is a single, continuous, cyclic quantity defined at every point in the universe. Its changes in time give the rhythms of reality. Its changes in space give the shapes of reality. The paths along which it stays constant give the motions of reality. Every derivative in the master tree, every omega, every k, every curvature and knot, is just a more detailed way of describing how phi behaves. No new ingredient is ever added. In earlier episodes, we saw that energy is not the basic stuff of the universe, but a way of counting the intensity of phi's changes. Now, in episode 7, we are seeing that even the language of reality, its letters, its grammar, its sentences, all emerge from one underlying rhythm. If the holophase framework is right, then the same phi logic that shapes quantum interference patterns also shapes the flows of fluids, the motion of galaxies, and the activity of brains. The same kind of derivative tree can be used to describe turbulence, optics, solid-state patterns, and more. And if that turns out not to be true, if different parts of nature stubbornly refuse to fit into the same phase-based language, then the holophase program must be revised or rejected. That is the power and the honesty of framing reality as a single language. It makes very clear, testable claims. 14. Closing movement. Feeling the root beneath the tree. As we close this part, I invite you to hold a very simple image. Imagine again the master tree of the Holophase language. At the top, an infinite canopy of subtle nuances. Higher derivatives, delicate curvatures, complex wave interactions, topological braids, and stable objects. In the middle, thick branches representing familiar structures, time rhythms, spatial shapes, motions, forces, and waves. And at the very bottom, almost easy to overlook, there is just one thing: phi. A single cyclic order, a clock hand at every point, a silent page waiting to be written on, already full of potential. Everything you see in the world, light, matter, motion, patterns, stability, chaos, is, in this picture, Phi speaking in different dialects of its own language. You have now met Phi not as an abstract symbol, but as the blank page that makes writing possible, the global clock hand that never stops turning, the continuous canvas that lets time, space, and motion be woven together. In the next parts, we will climb back up the tree and look at the first clear letters: omega, K, D phi, and V. We will see how they each carry a specific kind of meaning: temporal, spatial, unified, and kinematic, and how together they form the core alphabet of the language of reality. For now, remember this: beneath every derivative, beneath every pattern, beneath every law, there is one rhythm: phi. And by learning to read its derivatives, you are learning to read the universe itself. Peace be upon you.